So the unit step function is just this, u at t minus a. And all that is a flat line at 1 starting from some point a. It just goes this way. I should have drawn an arrow in there. It goes this way on to infinity, just forever that way, but it stops right there at a. Nothing over here, just 0. Just that simple. For a discontinuous function, you take your unit function, multiply it by some function. So now over here, our unit function is 0, so that other function, no matter what it is, also becomes 0. But here is we're multiplying it by 1, so it stays the same. So you end up with some sort of curve here that starts at a and just goes this way off into infinity. This is the Laplace transform of a discontinuous function e to the negative as times capital F at s. You're going to want to remember that one. I'll show you how to use it right away here. Our first example, you might get a question like this where they'll give you some function and they'll say find f at t, where this one here is defined as 0 this way. You have some function g at t here, and then 0 again after b. So how we would do that is we want to use the unit step function. Normally, unit step function starts at 1 point, goes off into infinity, so that's what we have here. U at t minus a times g at t minus a, the g at t is from right here. So that would be this function starting here, going off into infinity. But we don't want infinity, we want to stop at b. So we're going to use the unit step function again. But we're going to start at b. We're going to have t minus b instead of t minus a. So that's everything starting at b, going this way. But we don't want that, so we're just going to subtract it off. What you're left with is just the piece that you want there. Second example, find the Laplace transform of u at t minus 2 times t squared. Now remember, we need f at t minus a. In this case, our a is 2. So we need this t to be some function of t minus a, or in this case, t minus 2. So what we're going to do is we're going to take t minus 2 squared, which is t squared minus 4t plus 4. But we can't just plop that in there because that's not the same thing. It would change our function. So what we're going to do is we have the t minus 2 squared. We want to get rid of everything here after that t squared. So we're going to take the opposite of here. So we have plus 4t minus 4, and that gets rid of these two. If you multiply this out, collect your terms, you get t squared. But once again, we have t minus 2 here, but we have another t that we need t minus 2. So you do the same thing again. You multiply this out again, you'll get t squared. So now we have a function of t minus 2 that is the same as t squared. So we can just plot that right in our equation from here. It just goes right there. And if you remember our equation here, the Laplace transform of that, e to the minus as times capital F at s. So we pull the e to the minus as out here, that's e to the negative 2s, times the Laplace transform of f at s. So the minus 2 goes away, we're left with t squared plus 4t plus 4. And you can take the Laplace transform of that, it's very easy. Final answer is e to the minus 2s times 2 over s cubed plus 4 over s squared plus 4 over s. Math isn't so hard when you have the right tutor. Be sure to check out the description for links to other courses and topics. Also remember to tell your friends about the TheKFully channel.